Hello everyone, welcome to the machine learning using Python. This is the session 13 or you can call it module 7. This will be on clustering and our expert Jamit Basawa, the instructor, will lead you through the clustering concept. Hopefully this one, and if you need one more, next one also. So I will hand over with this to Jamit Basawa. Go ahead, Jamit. All floor is yours. Go ahead. Take care.
So,
Bye.
thank you. And hi everyone. This is machine learning using Python, and today we'll be covering clustering. This is module 7 and session 13. So, goals for today's session is to understand what is clustering, how segments can be affected while using the clustering algorithm, interpreting the clusters that are created using Euclidean distance in clustering, and understanding how to find the optimal number of clusters in data. So we'll go back, we'll start the discussion of clustering with the help of this recap of ML categories. So ML categories are divided into supervised, unsupervised, and reinforced. Now, in supervised learning, we have the outcome and we train the model to predict an outcome, and based on the difference between the the base thing in supervised learning is that we already know the outcome and we want the machine to predict the outcome based on the probability. In the supervised learning, we do not have the outcome and we let the machine learning model understand the data and give hidden patterns in the data set and give us an outcome based on the data that we have. In reinforced learning, the model learns based on the reward and penalizing the actions of the model. If the model is doing something that we want, we reward it, and we penalize it when we don't want the model to attempt it. And as you can see from the chart, that clustering falls under the unsupervised learning, along with association and dimensionality reduction. So let's just look at a few of the famous platforms which helps in educating based on the ML or machine learning, how they define clustering. So starting with Geek4Geeks or GFG, the task of grouping data points based on their similarity with each other and is called clustering or cluster analysis. This method is defined under the branch of unsupervised learning, which aims at gaining insights from an unlabeled data points. That is, unlike unsupervised learning, we don't have a target variable. Now, clustering from the machine learning data camp. Clustering is a process of arranging a group of objects in such a manner that the objects in the same group, which will be referred to as clusters, are similar to each other than the objects in any other group. How Google for developers define it is grouping related examples, particularly during unsupervised learning. Once all the examples are grouped, a human can optionally supply meaning to each cluster. And how IBM defines it, clustering is an unsupervised machine learning algorithm that organizes and classifies different objects, data points, or observations into groups or clusters based on similarities or patterns. So clustering does feel kind of similar to classification, but there are two differences between the clustering and classification. Clustering falls under unsupervised learning and it's a descriptive analytics technique, whereas classification falls under supervised learning technique. and falls under the predictive analytics. So the intuition behind clustering is to create heterogeneous groups and those group containing homogeneous records. So uh, how, how can we use clustering? So let's say an example that a company wants to increase its brand awareness. So it has to design a campaign, and uh, so if a company wants to design a campaign for anything, let's say a company is trying to any company is trying to design a campaign for its marketing, and it creates only one single campaign. Will that campaign be serving for all the segments that are existing in the market for anything? Of course not. It has to be targeted to someone or some of the segments which the company wants to target. So for this example, we'll consider an automobile company, tech company, and a skincare product company. So a car manufacturer can identify segments such as luxury sedan, eco-conscious people, and SUV fans as their uh, segments in the market. In the similar way, a tech company can focus on tech enthusiast, productivity focused professionals, and older individuals who want a very user friendly interfaces. In the skincare company, uh, there can be segments related to skin type, age, concerns, and preferences for different conditions related to skin, normal conditions like oily skin, acne prone skin, anti-aging skin, and stuff. So the companies have to understand the customer segments which are already existing in the market and which customer falls under which segment. So that is why clustering as a technique can be used to address such situations. So clustering is a divide and conquer method, and it can be sorry, it is carried out before applying any of the any other analytical model. And you in the image down below, you can see that if we plot the data points are having their own individual group of those group containing homogeneous records, and having the heterogeneous groups. So in clustering, the objective is to ensure that the variation within a cluster is minimized while the variation between the clusters, like you can see in the image, we have light blue, blue, and violet. The variation between the clusters is maximized. So clustering algorithms use different distance or metrics to calculate those distances, or similar or dissimilar measures to derive different types of clusters, or bifurcate the different clusters that are existing in the data set. So the type of distance similarity measure used plays whichever distance or the dissimilarity or similarity measure, whichever it's used, it plays a vital role in forming the final clusters that are given. So larger distance would imply that the observations are far away from one another, whereas similarity, sorry, higher similarity would indicate that the observations are similar. So we'll be using this income data set. So Uh, you can see that we are reading the data set using pandas and making a data frame called customers DF. Now that when we display few records from the data set, you can see how the index is there, then the income and the age of the person. Now, when we plot the data set using a scatter plot, you can see that there are certain formations formed on the plot. You can see that on the top left, there is a low age, high income group. In the top right, there is a high age, medium income group. And on the bottom, there is a low income group, but the age is very spread out. But in the end, you can see that there are almost three clusters you can form uh, in a very, yeah, if you start to look at the plots on the scatter plot, you can see that there are definitely three clusters being formed. So clustering techniques assume that there are subsets in the data that are similar or homogeneous. One approach for measuring similarity is through distances measured using metrics. Now, regression analysis assumes a linear relation between the independent and the dependent variables. Collaborative filtering assumes that the user with similar preferences in the past will also have similar preferences in the future. So, in the similar way, when clustering is used for data points are calculated using different distance calculating metrics. Here, we will be using the Euclidean distance in order to calculate that. And you can see that the Euclidean distance is a simple distance which is calculated with the help of a XY coordinate in a 2D plane. So if we compare the formula for the Euclidean distance with our case, you can see that it's a age and income. So our distance is given by square root of age1 minus age2 whole square plus income 1 minus income 2 whole square in order to calculate the distance between 2 points. So commonly used in clustering algorithms such as k-means and is a dimensionality reduction techniques like principal component analysis. Now the advantage to using the Euclidean distance is it's simple to understand and calculate and works well when the data attributes are on the same scale. Now there are other distance metrics that can be used based on different scenarios, such as Minkowski distance, which is good for generalized distance. Then Jaccard similarity coefficient. It is a measure used when the data is qualitative, especially when the attributes can be represented in binary form. Cosine similarity between 2 points x1 and x2 are two n-dimensional vectors. It measures the angle between the two vectors. And it's called vector space model. The Gore's uh, similarity coefficient, the distance and the similarity measures that we have discussed so far are valid either for qualitative or quantitative data. The Gore similarity coefficient can be used when both quantitative and qualitative features are present. Now, we'll be starting with a k-means clustering. So it's a clustering algorithm, which is a non-hierarchical clustering method where the number of clusters is predetermined before running the algorithm. So a non-hierarchical clustering, which is also known as partitional clustering, the data set is divided into fixed number of clusters without forming a hierarchical structure. Unlike hierarchical, and there is something called as a hierarchical clustering also, where clusters are nested within one another, and non-hierarchical methods create distinct separate clusters. So in K-means algorithm, the K is the number of clusters that uh, we want to create, and the value of K is in a way experimental, and we have to see whether how the data is in order to understand good a mo- uh, an optimal value of K. So one of the popular and non-hierarchical clustering algorithms is K-means clustering. The partitions into it partitions the data set into K clusters, where the clusters are represented by its centroid, which is the mean of all the data points in that cluster. So the algorithm iteratively assigns each data point to the nearest centroid and then recalculates the centroid based on the mean of the data points assigned to each cluster. So in k-means clustering, the value of the k is determined before running the algorithm, and determining the appropriate value of k, it needs to have domain knowledge, experimentation, and using the technique such as the elbow method or silhouette analysis. Now, a priori decision. So what is a priori? It means that the decision regarding the number of clusters is made before running the algorithm. This decision is typically based on the requirement of the problem of the analyst's understanding of the data. And choosing the correct number of clusters is crucial as it directly impacts the interpretation and effectiveness of the clustering results. So we'll use scikit-learn's uh, from scikit-learn's dot cluster. We'll be using k-means in order to use the k-means algorithm. So we fit the data of first we assign it to clusters for 3 clusters and assign it and fit the data of customers DF to that clusters. And when we fit the data, we get the values of the parameters used, and and uh, when we display the first few records of the customers DF according to the labels. So dot labels are something that is assigned by the k-means. So it is creating three cluster IDs, and based on those cluster IDs, all the data points are given the respective cluster ID. So as we have been creating we have created 3 clusters. So it will be 0, 1, 2. When we plot the graph using uh, when we plot the graph of the uh, customers DF on X and Y, for X equals to age and Y equals to income, you can see that how the different clusters are created for different age and income, and how they are created. You can see triangle, plus signs, and dot signs with their respective color of orange, blue, and green. Now, the previous graph was this is the same graph that we saw on the previous slide. Now, this graph is created using with the actual values that are present. Now, the age scale that we have on the data set is from around 20, sorry, from 25 to 50 or something. Yeah, it would be around it is around 0 to 60. But when we see about the scale of income, it goes from 0 to 50,000 or something. Now that's a comparatively larger difference compared to the age we have. So the segmentation of the data set is being done based on income. In order to have a normal view, we have to normalize these values, and that's why we will be using normalization on the data set. So these are some of the reasons to why we want to normalize. We have age and age difference from 0 to 60, and the income range is from 0 to 50,000. So without normalization, the clustering algorithm mostly uses income to determine clusters because the income differences are numerically larger. When we use normalization, we bring it into a single scale to compare. So after normalization, both the age and income differences are equally considered. This allows the clustering algorithm to identify patterns considering both age and income rather than being dominated by the income differences. So as we have been using normalization feature before also. So this is how we create for the individual record. It is deducted by the mean and divided by the standard deviation. But in scikit-learn, we have a standard scalar. So we'll be saving the values of the customers DF into scaled customers DF. And when we and get some of the values for the first few values of the customers GF, scaled values of the customers GF, you can see the output it gets for the first record in the order of age and income. It's 1.37, and for income it's 0.097 and stuff and so on. So now plotting the graph or the scatter plot for the different segments that are in our k-means algorithm. You can see how the graph looks like, and in order to get the mean of the clusters, we can use it cluster centers in order to get it, and you can see that we get different means. So the standardized values, we can calculate the cluster centers from the original data frame using the information which customers have been allocated to which segment. You can see the difference between the scatter plot before and after normalization. You can see the before normalization graph beneath the text, and after normalization scatter plot. So cluster centers and interpreting the clusters. Centroids are the mean of the observation of that cluster, so they explain the characteristic of the clusters and help us to interpret the cluster. For us, the cluster center provides the average age and average income of each cluster. So when we use we use the customers DF according to the cluster ID, and the age income is used in order to get the mean and standard deviation of both age and the income. So we created three clusters, 0, 1, 2, and for age you can see the average age is 31 and the standard deviation is 6, whereas in of course 6.122 and so on. For income, the average is 54K, 54.6K, and the standard deviation is 2.3K. And so for cluster ID 1 and cluster ID 2. So this is how we create, use the data set to create the data frame, displaying first few 5 records, then creating a scatter plot from the data set directly, and this is how the uh, scatter plot looks like. When we use the k-means clustering for 3 clusters, as we can see only 3 clusters, we use 3 clusters and fit the data of the customer's DF in the algorithm. You can see that the cluster, uh, the customer's DF has a cluster ID which contains the labels of the clusters that were assigned for 0, 1, 2. And when we plot the graph, this is how the graph looks like. Now, as discussed, we needed to normalize the values in order to consider both the age and income. We normalize those values and we again created the graph, and this is how the normalized graph looks like. Uh, Graph containing the normalized values of the data set. Then we grouped the cluster ID with age and income, and both age and income having the mean and standard deviation for itself. So as we have understood a basic clustering now, we'll be using an example of uh, a scenario. So we'll be using a company's example, which it wants to launch itself as a beer brand. So first, what it has to do is understanding the existing market and which products serve which existing segments. To understand the segments, the company collects specification of few samples of beer brands and will use that beer.csv dataset in order to understand how the segments are, how many segments are there, how they have created it, and based on what it can differ. So the beer.csv contains the features such as calories, sodium, alcohol content, and the cost. Now, when we'll be reading the dataset and making it BRDF as the data frame. Now we'll be using the standardized values for the BRDF. So the calories, sodium, and alcohol cost will contain the standardized values. Just a second. So before creating the clusters, we'll be normalizing the values of the BRDF data frame and storing it under scaled BRDF. Now that we want to create clusters, and there are two ways we can use it. One is dendrograms and the other one is elbow method. So starting with dendrograms. Dendrograms are key visualization tool for hierarchical clustering. They display the arrangement of clusters produced by the hierarchical clustering algorithm, and each merge into the dendrogram represents a potential cluster. To make a dendrogram, we will use a cluster map method from Seaborn. So you can see that there is a code on top left which uses the Seaborn's Q helix palette and uh, contains the the parameter values for it. As you can see, there is a parameter called rot, which is for rotation, and we have given it a negative value, so it rotates under a similar color wheel. And light means it will have the light equals to 1 means it will have the lightest tone. Now, the using the cluster map, we have used the scale values and others are line widths and stuff. So when we create this dendrogram, and you can see that there is a dendrogram that is being created on the right side of the screen for the beer dataset that we have used. So you So dendrogram reorders the observation based on how close they are to each other using their distances, or being specific, it's a Euclidean distance. Now there is a tree structure on the left of the dendrogram, which which tells us that how, according to dendrograms, how many clusters can exist. And you can see that there are four clusters that can exist. And and the dendrograms can also give us the most similar values as well as the least similar values. As you can see that the dendrogram starts with the first value as 2 on the very right. You can see the numbers. So the first value will start with 2, and the last value is 18, which says that those are the most different of the records, whereas uh, 10 and 16 are the one which have as the least kind of similarity, which are the most similar records. So in order to get to see those records, we can simply just use a df and iloc method in order to get those records. And you can see that 10 and 16, which are the most similar ones, have a similar kind of alcohol, sodium, and calorie content, as well as the cost. Whereas the most different ones, you can see that their calorie, sodium, alcohol, and cost contents are kind of different. Other than cost, everything else is different. Now, Lowenbrow has alcohol content of 0.9, which is very low. Now, that can be due to an error, or it can be an actual outlier. So we can drop that brand from the dataset. So the tree structure on the left of the dendrogram indicates that there may be 4 or 5 clusters in the dataset. The actual can be determined by creating and interpreting it. So for us, we'll be selecting 4 clusters according to dendrogram. If we increase the number of clusters over here, it means that we are trying to fit the records from the data set for each individual cluster, which kind of misses the point of creating the clusters and increases the complexity too when we increase the number of clusters. So right now we'll be moving and selecting that four are the clusters according to dendrogram. Now, dendrogram was one way to know the optimal value number of clusters. The second way was the elbow curve method or elbow method. Just a second. So elbow method helps determine to know the optimal number of clusters based on the variance as a function of the number of clusters. So the elbow point on the plot indicates that the optimal number of clusters, and we'll soon see how we do it. So for our case, if we assume all the products belong to only one segment, then the variance of the cluster will be highest. And as we increase the number of clusters, the total number of the total variance of all the clusters will start reducing or start distributing, but the total variance will be zero if we assume that each product is a cluster by itself. So that's what I said, that we cannot increase the number of clusters and we so much that each individual cluster will have its own own segment. Sorry, each individual record will have its own cluster. So elbow curve methods helps us based on the explained variance by the algorithm to know the number of clusters. So mathematically speaking, within clusters, the so WCSS, which is within cluster sum of squares, sorry, uh, which helps us to understand the formation of clusters based on the calculation from of Euclidean distance. So percentage of variance explained tells us how well the clusters capture the patterns in the data. Adding all the clusters in one will result in a lot of variations, whereas having too many clusters will increase the complexity. So for number of clusters and when we plot the graph of for a number of clusters against the percentage of variance explained by the algorithm here, you can see that first the as for the variance as sorry. So first the graph will rise steeply, then it starts to flatten out. So the point where it starts to flatten out forms a kind of bend or a elbow-like structure. That is why we call it a elbow curve method. So this bend suggests that adding more clusters beyond this point won't give you much of the explanatory power, or having more clusters than that does not uh, give us any benefit and also adds to more of the complexity. So you can see if we plot for us, this is how the graph looks like, by the way. If we create the graph for our cluster, we'll be using the uh, a range of 1 to 10 in order, and for that we'll be using the k-means and num clusters and fit the model with the a scale BRDF for our k-means clusters. So you can see that when we plot the graph starts to bend at 3. Now there can be many possible values, and based on the experimentation or based on the experimentation and the domain knowledge, you can create a more you can interpret these values as 3, 4, and 5. These are not final values, but rather a guideline too. So for us, we'll be going further with 3. So normalizing these values and transferring the uh, just a second. Yeah, so so we'll be creating 3 clusters and using k-means again for the scale values of BRDF, and saving the labels that are created by the k-means clustering in the cluster ID. So when we save those values and see that which are the uh, which are the names given by the algorithm for cluster ID equals to 0, you can see the records that are there. Now these contain these are the now this segment contains the largest number of records, or this is the largest segment with a medium alcohol and medium price or the cost grouped together. When we go for cluster ID equals to 1 and cluster ID equals to 2, you can see that in cluster ID 1, that is low alcohol, low calories and sodium content being grouped together, and in cluster ID 2, the alcohol content is relatively high and the sodium content is also low. So the cluster ID 2 are the ones that can be concluded as a premium brand and are targeting the people who are brand sensitive. Now let's look at hierarchical clustering. So according to Geek for Geeks or GFG, in data mining and statistics, hierarchical clustering analysis is a method of clustering analysis that seeks to build a hierarchy of clusters, that is tree type structure based on the hierarchy. We'll be using agglomerative clustering, which is a kind of a hierarchical clustering. And when we use a agglomerative clustering, you can see that in step 1, we have A, B, C, D, E, F, all those clusters. In step 2, we merge B, C, and D, E. And in the step 3, we merge B, C, D, E. Sorry, we merge D, E, and F. After that, in step 4, we merge B, C, D, E, F, and in the end, in step 5, we merge all of them together. Now, a guideline for creating a clustering algorithm, for using a clustering algorithm, will be start with each data point in a single cluster, find the data points with the shortest distance and merge them to form a cluster. Repeat the step 2 until we form a single cluster. So which is for we are discussing agglomerative clustering. So we'll be using scikit-learn's agglomerative clustering and saving our values in H clusters. When we fit the values of scaled BRDF and adding a column of H cluster ID, which is according to the hierarchical clustering, the labels given to our scaled values in the data frame, you can see according to the hierarchical cluster IDs given as 0, it's the same as that was given by the previous cluster IDs as 1. All of the values are same except the interchange of the cluster IDs. The same goes for H cluster ID or hierarchical cluster ID equals to 1 and hierarchical cluster ID equals to 2. For cluster ID and H cluster ID 2, the values are same and even the IDs are same. And so basically the clusters created are same except the only change is that the cluster ID is changed. So we used beer we created BRDF from our data set, and these are the values of the these are the values that are in the data set for different values for different brand names, calories, sodium, alcohol cost, etc. Then the two ways that we can know about the number of clusters that we can create are dendrograms and elbow method. First, we tried it with dendrogram. If I zoom out a bit, you can see the whole dendrogram. And according to dendrogram, there were 4 to 5 clusters that were created. So those were the values, and we decided to go with 5. And these are the least similar values, whereas 10 and 16 were the most similar values. And these were the values of 10 and 16 as well as 2 and 18 for the most and the least similar values. Then we used elbow method or elbow curve method in order to understand. And when we plot the graph for the variance explained by the algorithm to the number of clusters to make, you can see that the curve starts at 3, 4, or 5. Now, depending on your choice, you can go with any 3 of these values. We went with 3. So we standardize the, we went with 3. So we went k equals to 3. And um, based on that, the clusters were created for a cluster ID 0, 1, and 2. Depending on the cost and alcohol content, then sodium and alcohol content, and the last one being low sodium content, more alcohol content, as well as the premium cost. Then we discussed about a hierarchical clustering, which was agglomerative clustering. And according to agglomerative clustering, when we used the value of 3 for it, or creating 3 clusters, all the values that were created before were created same, except the very difference was the change in the cluster ID. Other than that, all the clusters that were created were same. So in this session, to summarize, we learned about clustering, how it's an unsupervised learning. We compared it with a classification, which is a supervised technique. Then we saw that how creating more how the segments can affect depending on the values that it contains. In our case, we first took an income data set, which contains income and age of the individuals. And because the differences between income was very large, it used to dominate and create the segments based on income, whereas we wanted a more normal and generalized approach in order to consider both income and age. So that's why we normalized those values and again created the cluster. We used Euclidean distance in order to understand clustering. Then, in order to find the most optimal number of clusters, we used a different use case, which was regarding the beer data set, and those depending on those values in the data set, we used dendrograms and elbow curve method in order to get the optimal numbers. According to dendrograms, we got 4 to 5 clusters, and according to elbow curve method, we got uh, 3, 4, and 5 again. But we went with dendrograms for value of 4 and elbow curve for value of 3. So yeah, this is it for the session on clustering. These are some of the references used in order to make this session. So I hope it was a fun session to uh, go go about and understand. So thanks a
Thank
lot.
you. Thank you, Jamit, for the excellent presentation on clustering. Look forward to again call on next within 2 days for the next one, and hope to see you then. And I'll end the call here.
Yeah, sure.
Thank you. Thank you very much.
Yeah, thank you so much.
Yeah.